Okay, in this second video where I am going through the review for test 6, we'll start with number 10. It says determine whether this point 2, -1 is a solution to this system of equations. Now you don't have to solve the system. All you have to do is plug in 2 for x and -1 for y and see if this point or ordered pair is a solution to both of these. So for the first one, we'll have 3 times 2 minus -1 equals 7. So we want to know if that's true. Well, this is 6 minus -1. Well, that's 6 plus 1, so that does equal 7. Here we have x minus 2y, so x is 2. And minus 2 times y, which is -1. We want to know if that equals 4. So this is 2. You could multiply 2 times -1, which is -2. We're subtracting -2. This is going to end up being 2 plus 2. And so, yes, that does check. So don't forget to answer. It says determine if it's a solution. The answer is yes, because the point worked in both equations. Let's move on to number 11. I'm going to have to make this a little bit smaller here. All right. So on number 11, this is going to be pretty easy because for the first line here, the slope is 2 or 2 over 1 since we need a rise and a run. And the y-intercept is 0, 4. And that's all we need to graph this first line. So we'll start at 0, 4. We'll rise 2, 1, 2, and run 1. And that puts us here. Now the only thing is this has taken us this way. Our intersection will probably be over here somewhere. Notice you could also go down 2, left 1, down 2, left 1, down 2, left 1. Let's do that a few times. Down 2, left 1. Hopefully that's enough. Certainly gives me makes it easier to draw a nice straight line. I did okay. A little bit off there. On the other line, our slope is -3 over 1. Keep in mind, we could put the negative with the numerator or denominator, so we'll see which one we want to use as we try to get or graph our line. So our y-intercept is 0, -6. So you can see we don't really want to go down 3 and right 1. That would put us about here. We want to go the other direction. We're looking for an intersection over here. So let's go up 3, 1, 2, 3, left 1, up 1, 2, 3, left 1. And you can see there's our point of intersection right there. Now don't forget, the solution is that point of intersection, and so that's what we want to say. -2, 0, that's our solution. And let's go ahead and box it in so it's nice and clear. So don't just graph the lines, make sure you tell me what the solution is. Now in letter B, I think here I would probably want to use the intercepts because it's this is in standard form. And notice 1 here divides into 4, and so does 2. So the intercepts will be a pretty nice way to do this. If I let x be 0, then we have 2y equals -4. 0 plus 2y is just 2y, which means y is -2. If I let y be 0, now I'm finding the x-intercept, we would have 2x minus 0 equals -3. Oh wait, I'm sorry, I'm on the wrong equation here. We're still on the first one. So we're letting y be 0. We have x plus 2 times 0 equals -4. Well, that's just 0. X plus 0 is x. And so x is -4. So 0, -2. and negative 4, 0. That's these 2 points here. Let me see if I can draw a nice straight line here. Remember, we're looking for a point of intersection. All right, so there's that line. It's not a bad idea to label it x plus 2y equals negative 4. I should have done that over here. Let's see, this one was y equals 2x plus 4. And then this was y equals negative 3x minus 6. All right, let's go ahead and graph the other line. So in this case, notice 2 does not go into 3. So I'm thinking I'm not going to use the intercepts. I mean, you could. It's not too bad of a point, but I think I'm going to solve for y. So let's subtract 2x. Remember, using the slope and the y-intercept is always a really nice technique. The only downside here is I have to solve for y. These add up to 0. We get minus y equals negative 2x minus 3. So I'm going to want to multiply both sides by negative 1, so I get a positive y here. So each term will change signs. That's all that happens when you multiply each side of this equation by negative 1. Each term changes signs. So now we can see our slope is 2, or 2 over 1. And our y-intercept is 0, 3. So here's 0, 3. We'll go up 2 and right 1. That puts us here. Again, notice that's taking us away from the intersection we're looking for. We can go down 2, left 1, down 2, left 1, down 2, left 1. It looks like we just found our point of intersection. And this is negative 2, negative 1, and that point of intersection is our solution. All right, let's move on to the next page. So we're going to solve using substitution on a and b. So this first equation is literally begging us to use substitution because we've got the first equation solved for y, and so all we need to do is substitute for y in the other equation. So that's why we call this the substitution method. The first step is a substitution. So this will become 3x plus, well, we're replacing y with 3x plus 5. And that's equal to negative 1. So basically, we're replacing this y in the second equation with 3x plus 5. Now, we don't really need the parentheses. We can just drop them. And we'll have 3x and 3x is 6x. The plus 5, we can't do anything with that. Notice now we have a two-step equation. We'll need to subtract 5 on each side. And we're going to get x is negative 1. Now remember, we're looking for a point of intersection. If you graph these two lines, normally we expect they meet at a point. Our solution that we expect is supposed to be a point. So we found x is negative 1. To find y, let's use the equation that's solved for y. So y equals 3x plus 5. We're going to put in negative 1 for x. So y is equal to negative 3 plus 5, which is 2. So our solution is the point negative 1, 2. Now if you wanted to, you could check, put 2 in for y and put negative 1 in for x, and it would make both of these equations true. So you could certainly do that if you want to check your answer. Normally when you get nice integer values, you're probably okay, but you can check your answers. Now for part B, it's not really crying out substitution here. We don't see x or y by itself, or it's not like this one where you have this solved for y. There's nothing like that here. So we've got to decide, since we have to use substitution, which variable should we solve for in which equation? What we're looking for is the 1 here. This is going to be the easiest one to work with. So we want to solve for y in the second equation. So we're going to subtract 6x on both sides. Well, these cancel. You get a minus y equals negative 6x. Now that's a plus 1. Make sure you, or a positive 1, make sure you write plus 1. And we know we need to multiply by negative 1. Whoops. Because I need a positive y. So each of our terms will change signs. And so now I can substitute 6x minus 1 for y in the first equation. So there's our substitution. So we have 2x plus 3 times our substitution equals 7. So that's the first equation. We're going to replace y with 6x minus 1. So it's always important that you use both equations. Notice here we solved the first or the second equation for y and substituted for y in the first equation. All right, so now we have 2x plus 18x minus 3 equals 7. We got a couple of like terms. We get 20x minus 3 equals 7. We'll add 3 to both sides. This is a two-step equation. We get 20x equals 10. Now be careful. You've got to divide by 20 here. You're not going to get 2. You're actually going to get a half. So our solution, x is a half. And actually, we need to find y. Remember, y is equal to 6x minus 1. So it's 6 times a half minus 1. 6 halves is 3, and 3 minus 1 is 2. So our solution is the point 1/2, comma 2. So don't fret that you get a fraction here. If you get a fraction on the test, it'll be a pretty simple one to work with, kind of like what we have here. All right, let's move on to elimination. So number 13 is definitely crying out, use elimination, right? Because 4y and a minus 4y, when we add these equations together, which is what we do with the elimination method, we should eliminate x or y. And so here, when we add the left sides, we're going to get 8x is equal, and then the other side you get 32. So you can see that x is 4. So far we found 4 for the x value of our solution. We can use either equation here to find y. So I like the first one a little better, but it doesn't really matter which one you use. You should get the same answer. So x is 4. So we're going to get 12 plus 4y equals 8. This is a two-step equation. We'll want to subtract 12 on both sides first. Get 4y equals negative 4, which means y is negative 1. Now, here, you can't just add the equations together, because notice when I add the x terms, I won't eliminate x. And when I add the y terms, I won't eliminate y. So in order for this to work, when we add the equations, we need to have opposites for x or opposites for y. Now I kind of messed up here because I used the space I usually use. Let's just do this. We're going to let's try to get opposites for x. We have a 2x here. Let's get a negative 2x here. So we're going to multiply this equation by negative 2. So normally I try to write them across, but I'm just going to put it down below. So we have 2x plus y equals 11. That's our first equation. And on the second one, we're going to multiply each term by negative 2. We're basically multiplying both sides of the equation by negative 2. We get negative 2x minus 6y equals negative 36. Now when we add the equations together, we get the x's to eliminate. 1 and negative 6 is negative 5, so negative 5y. Oh, let's see, negative 36 plus 11 is going to be negative 25. And so if you divide both sides by negative 5, you're going to get y equals 5. So now I have a choice. I can use any of these equations, the first two we had here, or I could even use the one that we did here. Normally we're going to want to use one of the originals. I'm going to go ahead and use the first one. We know y is 5. So this is just a two-step equation. We get 2x equals 6, so x is 3. So our final solution is the point 3.5. All right, let's move on to number 14. So it says solve using the method of your choice. I'm thinking of using substitution here since the second equation is solved for x. So I'm going to substitute for x in the first equation. So we'll have 2 times 20 minus 2y plus 4y equals negative 24. It's just the first equation, but I replaced this x with 20 minus 2y. So we'll have to distribute here. We get 40 minus 4y plus 4y equals negative 24. Now notice what happens. Our y terms add up to 0. So we get 40 equals negative 24, which tells me, well, that's a false statement. And anytime we get a false statement when we're solving an equation, we know we have no solution. In fact, this is the case where these two lines are parallel, and that's why there is no solution. These points or these lines don't intersect. By the way, I know my voice is fading. I hope it's not too bad. Now, if you look at B, there's not really a nice choice as far as we can't just multiply one of the equations by something. Notice nothing times 2 is going to give us a negative 3x. Nothing times negative 2 here, that's nice, is going to give us a nice plus 5y. Oh, excuse me. So we're just going to go ahead and multiply each of the equations by something. So what do I want to get here? I need opposites for x. Notice if I do 2 times 3, that would give me 6x. And I want my other one to be negative 6x. Now I could have had this one negative and this one positive. It doesn't matter. We just got to make sure we multiply by the right number. So to get the 6x that I want, I need to multiply by 3 here. But again, you'll have to multiply each term by 3. So we'll get 6x minus 15y equals 30. And to get this negative 6x, I need to multiply this 3 by negative 2. So here we're multiplying by negative 2. And again, we'll do that to each term. So we got the negative 6x here. Negative 2 times negative 2y is a plus 4y. And negative 2 times negative 7 is 14. So now when we add the equations, we do have opposites for x. Negative 15 and 4 is negative 11. So negative 11y equals 44. Divide by negative 11, you get y is negative 4. So we have our y value. Let's find x. So I think I'm going to use this first equation. You could use this one. You could even use one of these. But we want to keep our numbers small. We might as well use one of the first two. So let's use 2x minus 5y equals 10. And we know that y is negative 4. So this becomes 2x plus 20. Notice we have a two-step equation. We'll need to subtract 20 on both sides. and divide by 2, or you can just do that in your head. X is negative 5. So our final answer here is the point negative 5, negative 4. All right. Let's see, we have one last page, and there's a couple of word problems. I think I'll just try to finish this out. So notice here, John has 35 coins, all dimes and quarters. If the value of the coins is $6.95, how many dimes and quarters does he have? Well, we have two equations we need to write. We're using systems to solve word problems. We'll say we have to find out how many dimes and quarters there are, so let's let X be the number of dimes. And let's let Y equal the number of quarters. And since the total number of coins is 35, that means X plus Y equals 35. And then now that deals with quantity, or how many coins there are. The other equation is going to deal with value, the value of these coins. In this case, the value of the coins is $6.95. So what's the value of our X nickels? Well, each nickel's worth 5 cents, so it's 5 cents times the number of nickels. So if you had 7 nickels, the value of those 7 nickels would be 7 times 5 cents, or 35 cents. The value of Y dimes is going to be 0.10Y. And so that's your system of equations. Now, just to save time here, because the most important thing with these is that you can set them up, I'll go ahead and put the solution up here. Whoops. So notice what I did is I solved the first equation for Y. And so I replaced Y here in the second equation with 35 minus X. So you had to distribute here, and so that's what I did first. And then I added my X terms. A negative 0.25 and a positive 0.10 is negative 0.15. And then this is just a two-step equation. So I subtracted, and I did it over here, I subtracted 8.75 from both sides. And then I had to divide by negative 0.15, and you get 12. And I would just remind you, so we have 12 dimes and 23 quarters. Notice the number of dimes plus the number of quarters is 35. And you can also check the value by doing 0.10 times 12 plus 0.25 times 23. And that should be 695. That's what I did here. All right, so let's look at the next equation. Again, the most important thing is I want you to know how to set this up. Now this is a rectangle that we're dealing with here. It says the perimeter of a lot. We're kind of assuming it's a rectangular lot. Maybe they should have stated that. But they're talking about length and width, so we're dealing with a rectangular lot here. The perimeter is 110 feet. Now we have a formula for perimeter. It's perimeter equals 2 widths plus 2 lengths. In fact, we have 2 widths and we have 2 lengths. Notice we're using W for the width and L for the length. So we really could change this to 110 equals 2W plus 2L, since they told us the perimeter is 110. There's one of our equations. Now the other one, you need to be able to translate that equation. The length, that's L, is equals 7 feet more than twice the width. So twice the width is 2W. If you want 7 feet more than that, you would add plus 7. It's like if I said 7 more than 100. You would start with 100 and add 7. If you want 7 more than twice the width, you start with twice the width and add 7. And so now we can substitute here into the other equation for L. And again, I'll put up the solution, and just to make things, whoops, did I mess this up? Sorry, I don't know what happened there. My screen left me there. Hit the wrong button. Okay, so I substituted 2w plus L into the first equation for L. I'm sorry, 2w plus 7 I substituted for L. And so you get what's here. So you have to distribute and then combine your like terms. You get 110 equals 6w plus 14. You end up getting w is 16. Then you can find the length by using L equals 2w plus 7, which is what I did here. So your width is 16, and your length is 39. And those are both in feet, which notice I said here. To check it, notice you can plug the 16 in for W and 39 in for L into this first equation, and you should get 110, and that does work. And the second one, the length, which is 39, should equal twice the width plus 7, which is what we have here. And it does. All right, so that's going to be it for this review. Let me know if you have any questions.